Assalamu alaikum guys, welcome back. Okay, so now in this video we're going to talk about a special type of covalent bonding known as additive bonding. We've talked about polar and non-polar covalent bonds under the heading of normal covalent bonding. Okay, so a quick recap. Covalent bonding is of two major types: normal covalent and dative covalent. Dative bonds are also known as coordinate covalent bonds. Okay, now the normal covalent bonds are of two types: polar and non-polar. Polar in the case when the electronegativity is different for both the bonded atoms, and non-polar in the case when the electronegativities are similar or equal for the two bonded atoms. Okay, now dative bonding is actually the same as covalent bonding, but it's a special type of covalent bonding. Remember, in case of covalent bonding, the the electrons were shared. In dative bonding, it's actually one of the two bonded atoms that provide both the electrons for the sharing. Okay, so one atom provides the two electrons of the bond, the covalent bond. Okay, such type of covalent bonding is known as a dative bonding, and classical examples are ammonium, water, and Al2Cl6. These are three examples given in our syllabus, and let's look at them. First of all, for example, if we've got, and there is a condition that must be fulfilled before this dative bonding can occur. If we've got one atom A and another atom B, let's say this atom is the one that provides both the electrons. So in this atom A, the condition is that it must have at least one lone pair, so greater than or equal to one lone pair of electrons. I hope you guys know what lone pair of electrons are. Lone pair of electrons, lone pairs are those pairs of electrons which are not involved in bonding. For example, this is oxygen. These are its lone pairs in case of a water molecule. Okay, it has two lone pairs because these are the two electrons which have not been used in the covalent bonds which it forms with water, with hydrogen. Okay, now at least greater than or equal to one lone pair of electrons must be present, and in case of B, since B is accepting the two electrons, it must have at least one vacant orbital. It must have a vacant orbital must be present. Vacant orbital must be present so that it can have room to accept the incoming electrons. Okay, if it is already filled, then it cannot accept the electrons because it won't have any orbital free, empty in order to accommodate the electrons. And if it doesn't have a lone pair of electrons, then of course it cannot give the lone pair of electrons to the other element. So this A must be electron rich, meaning having a lone pairs of electrons, and B must be electron deficient, meaning it must have the tendency to accept the lone pair of electrons. Okay, so only in that case, if this has a lone pair of electrons and this has a vacant orbital, a dative bond can be formed, and a dative bond is represented by an arrow. Okay, and the tail of the arrow must be pointing towards the lone pair of electrons, and the tip of the arrow must be pointing towards the element which is accepting the electrons from the donor atom. And this is the concept of dative bond. And after the dative bond is made, this bond, it acts as a normal covalent bond. Okay, meaning the two electrons which A provided, out of the two electrons, one electron would now belong to B and the other one will stay with A. So this means A has lost one electron. Okay, A has lost one electron to B. Okay, although it is being shared, but now after the bond has been made, it will act as a normal covalent bond. After it is made, normal covalent bond, and therefore A will get a positive charge because it has lost one electron, and B, since it has gained that electron, it will get a negative charge. Okay, now this concept is the entire concept of dative bonding. Okay, then let's come to the examples now. Okay, how is an ammonium ion made? Okay, you've heard of ammonia gas, right? NH3. When NH3 combines with H positive ion, it can form what? Well, this is a reversible reaction. It can form ammonium. Okay, now what actually happens is that this ammonia, the nitrogen of ammonia has a lone pair because it belongs to group 5, and these are the 3 hydrogen atoms that it has. So this nitrogen has a lone pair, it's empty, and this hydrogen H positive, how many electrons does it have? Hydrogen has no electrons, by the way, when it is in the positive charge. Reason? Because it already had one electron, and if it had given that electron, donated that electron, then it would have no electron left. This is just the nucleus, the proton of the hydrogen. So that's why H positive ions are also known as protons. Okay. Now this nitrogen, what it will do is it will donate its lone pair of electrons towards this H positive ion, because this it has this lone pair of electron, and the hydrogen itself has an empty orbital, so it can accept that lone pair of electron, and as a result of this you will get a nitrogen and the 3 hydrogens which it already had, and this nitrogen will get a positive charge. The reason, because it has lost one electron, and this hydrogen already had a positive charge, so the negative charge that it was supposed to get, it didn't get that, but rather this positive charge got nullified, okay, because it already had a positive charge. You can write it in this form, or you can just put a bracket outside of this entire molecule and place a plus charge over here, okay. Then after this, hydronium, how is hydronium ion formed? H3O positive. Again, same concept, water combines with another molecule of water and forms H3O positive along with OH negative. Now this H3O positive that is made, it will accept a proton from another water molecule, okay. So this is water, okay, and this is another water molecule. Now remember, oxygen is more electronegative than hydrogen, so this oxygen has a partial negative and the hydrogen has a partial positive charge. Same applies here, say partial negative, and hydrogen has a partial positive charge. Now it will use the 2 electrons and transfer both of them to the hydrogen atom, okay. This transfer of 2 electrons is shown by a curly arrow, and as a result of this bond will break and both the electrons will be transferred to the oxygen atom. The reason why both of them will be transferred, because oxygen is more electronegative than the hydrogen, and as a result you will get a third species, which is hydronium, okay, in which there is a dative bond and 2 hydrogens that it already had, and 1 lone pair which is left, and the whole thing will get a positive charge, and that's it. Actually, wait, yeah, whole thing will get a positive charge, and along with this you will get an OH negative ion, because the OH had accepted the 2 electrons, so it will get a negative ion. This is how hydronium is made. And finally, you can Al2O3, I would want you guys to try it yourself, and the example has been given in the book as well. I'm not going to draw that out. Okay, so this finishes off the dative bonding. In the next video we are going to do the types of covalent bond, that is the sigma bond and the pi bond. Thank you so much.